Alright, scholars. So we know that in a circle there are 360 degrees. The question is, how many radians are there in a whole circle? Alright, now remember, we said that radians just mean how many times will a radius length fit in some chunk of the circumference. Okay? So how many of these lengths are there in here? Alright, so if we want to know how many radius lengths are in the whole circumference, how could we figure that out? Alright, well, what is the circumference of a circle? We know that it's 2 pi times whatever the radius is. But wait, what did we just say? We said that the whole distance around is just the radius 2 pi times. Well, how many times is 2 pi? Now remember that pi is just a number. A lot of people get confused because it looks funky. It's a weird Greek letter, right? But it just stands for some value. It's just a numerical value. Pi is roughly 3.14, blah, blah, blah. It's just a little bit over 3. So 2 pi would just be a little bit over 6. It's like roughly 6 1/3. Just think of it as 6 units and a little bit extra. Alright? So if the circumference of a circle is 2 pi times the radius, that means that the radius could fit in the circumference about 2 pi, or a little bit more than 6 times. So let's see if we can just sketch that out. So I want you to imagine that here's the radius length here in blue. Imagine that it's flexible. It's like a rope or something like that. And I'm going to try to lay it around the outside of the circle. So there's 1 radius length, there's 2 radius lengths, there's 3 radius lengths, there's 4, there's 5, and, well, roughly 6. But that just goes to show you that you can fit a radius length around the circumference roughly 6 times. Alright, so that's why there are 2 pi radians in a circle. And again, we're measuring the angle. Alright, so from 0 all the way back around to where we started, that is 2 pi radians. Okay, now let's talk a little bit about how radians are related to degrees. So up until now in your mathematical lives, you've probably only worked with degrees. They seem really natural to you. So your goal now is to become comfortable thinking about angle measurements in terms of radians instead of degrees. So let's look at a circle and let's figure out how radians are related to degrees. So we know that 1 complete rotation, we just said, is 2 pi radians. So 360 degrees, that's the same thing as 2 pi radians. Now, if we know that the whole thing is 2 pi, let's figure out what the in-between angles are. Alright, so if the whole circle is 2 pi, then we know that half of a circle, aka 180 degrees, should be half of 2 pi, which is just pi. Alright, so the fact that pi radians equals 180 degrees, that's going to be very, very useful to you. So try to internalize that as much as you can. Alright, now let's break down pi radians even more. So 90 degrees, well, that's just half of pi, half of 180. So 90 degrees is equal to pi over 2 radians. Alright, now let's talk about 270 degrees down here. Notice, if this is 0 radians, this is 1 pi over 2 radians, this is 2 pi over 2 radians, aka pi, then this guy down here will be 3 pi over 2 radians. You could also see from that logic that if you keep going around to 360, that would be 4 pi over 2 radians, which is just 2 pi. So this skill of counting around the circle by fractions of pi, that's going to be very, very useful to you. Now let's talk about the angles that are not the boundaries of the 4 quadrants. Alright, let's talk about angles 45 degrees And let's talk about 135 degrees. Alright, so if 90 degrees is pi over 2, then half of 90 degrees, 45, should be half of pi over 2 radians. So that's just pi over 4. Alright, now let's figure out how many radians 135 degrees is. If 45 is 1 pi over 4, and 90 is 2 pi over 4, then 135 should be 3 pi over 4. Alright? So here we have a degree of 225. And let's figure out how many radians that should be. So we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. Alright, we can continue. This is 6 pi over 4, but we already have that angle. And here we have 7 pi over 4 radians. And that is 315 degrees. So finally, let's talk about the angles that are multiples of 30 degrees. So 30 degrees is what fraction of 180? Well, it's a sixth. So in radians, 30 degrees should just be a sixth of pi. That is pi over 6. So to find out what is 60 degrees, what is 120 degrees, what is 150 degrees, in radians, we're just going to count in multiples of pi over 6. Alright? So 30 degrees is just 1 pi over 6. 60 degrees is 2 pi over 6, which you can convince yourself is just pi over 3. 120 degrees, 90 degrees is 3 pi over 6, which is just pi over 2. 120 degrees is 4 pi over 6, which is 2 pi over 3. 150 degrees is 5 pi over 6. And 180 is just 6 pi over 6. 210, 7 pi over 6 radians. 240, 8 pi over 6, which is just 4 pi over 3. 270 will be 9 pi over 6. We already have that. 300 is 10 pi over 6, which I'll just reduce. And 330 is 11 pi over 6. So again, we're just counting by sixths of pi to figure out what the angles that are multiples of 30 degrees, what are those in radians. So those are all the most important angle measurements in radians. Now let's talk about, say somebody gives you a random degree, like say 35 degrees, and you want to know how many radians is that? Well, you can set up a proportion, because you know that pi radians, that is just a little bit more than 3 radians, is equal to 180 degrees. You can set up a proportion. You can say 35 degrees is to 180 degrees as how many radians is to pi radians. Alright, so you can do that, and you can always just solve for x by cross multiplying. It's probably the easiest way. So here we'll have 180 times x equals 35 pi. Just divide both sides by 180 and crank that out on your calculator, and whatever you get there, that's your answer. So that's how many radians 35 degrees is. And this works out to be about 0.61 radians. Alright? Now, let's say that somebody gives you a random radian measure. Let's say somebody gives you, let's just say 2 radians. And the question is, how do you translate that into degrees? Well, again, you can just set up a proportion, knowing that pi radians is equal to 180 degrees. So what we're going to do is we're going to say 2 radians is to pi radians as how many degrees is to 180 degrees. And again, just cross multiply. So we'll have pi times x equals 2 times 180. Divide both sides by pi. And we're left with x equals 360 divided by pi. which is about 114.6 degrees. So that's how to convert between radians and degrees and vice versa.